Hi, thank you. By the way, do you know what my last name means with one N? In German, obviously. Yes, something to eat, which is? Hard. Hard to eat. Yes, horseradish. But in Austrian German, it's Krenn is the Meerrettich thing. Anyway, so I want to talk a bit about logging. Like, probably you start developing your application, and it looks something like this, and everything is good. And then you start putting it somewhere to run, and then you do cat. And at some point later on, you maybe figure out, well, I want to use tailf because, well, I want to see what is going on. And at some later point, you start using less plus capital F. Anybody knows what less plus capital F is doing? It's doing the same thing as tailf. The only thing is you can break out of that with Control-C, and then you can search for stuff and go up and down, like in VI, for example. So / whatever search term you're searching for. You can just search in a file, or you can just go up and down, and if you go back to +F mode, it continues tailing your file, which can be kind of the advanced version. But obviously this is not really good enough, because oftentimes we're sitting then there and saying, this is fine, and everything is almost on fire, but you're still saying, well, this is kind of fine. And then you're going to production, and probably you have something that is more distributed, and then stuff starts looking like this. So you have 3 SSH windows, and you just try to see stuff. And then you have even more services, and then it looks something like this, where you see 1 line per server anymore, because you don't really know where stuff is happening anymore. And then everything is not fine anymore. And then everything is kind of on fire. And we basically want to avoid that place and want to get something easier. So that's the general idea. So we basically want to log all the things, and let's see where we can take this. So yes, I work for Elastic. That's why I'm talking about that. My official title now is developer advocate, but nobody knows what that is anyway, and I always use this avocado because it's much friendlier and everybody is like, fruit. Also, if you print your badges, you can always see which conference can print badges properly. If you have the emoji in there, which is kind of an interesting test. Anyway, so I'm not sure how many questions there will be and how much time we will have at the end. But if you have any questions, you can post them on Slido, and I can look. If you're too shy to ask in person, we can look at Slido at the end. Or if we run out of time, I will just tweet out the answers to various questions. Please don't put any offensive stuff or stuff like that there, which I might show afterwards, because it's always awkward. So if you go to slide.do/my Twitter handle is also where the answers, if we don't have enough time, will come out at the end, but you can just post anything at any point in time, and then we'll see how stuff progresses. Okay, so I guess everybody remembers the good old ELK, Elasticsearch, Logstash, Kibana, and well, that worked well for a long time, and I think this is 3 of the logos of people using us, but well, let's not cover use cases too much. And then we figured out, well, there is this speech thing, and then we had the ELK-B or BELK, but since we're always about scaling, this doesn't scale marketing-wise, because what happens if we have another open source product, and then we have another letter, and then we need to make up another animal, and it gets harder, and getting rid of old marketing is always hard. So this was the plan to have this, and we do have some stickers with that now, but it's not any official branding. So the BELK or the ELK-B was only kind of a temporary solution. So we just call it now the Elastic Stack, and whatever open source components we have, we put into that. And yeah, the artwork we're doing is getting better. So maybe you remember the initial logos for Logstash and Elasticsearch, like the wooden log and everything. Back then, basically the founders of the project were using Photoshop, and you could tell. By now, we have a more professional graphics team to create stuff like that. But it's kind of the same thing, and we will mostly cover like how to use this layer to collect stuff and work with stuff, to put it into Elasticsearch, and then maybe show it in Kibana. So that's the general idea. And all the stuff I'm showing you today, I think, is Apache 2 licensed, or at least free, so you can go pretty crazy with that. So I generally build highly monitored Hello World applications. This is no exception today, though I think I just broke my demo, of course, because I upgraded to an unreleased snapshot. I can show you some new stuff, but I have also some broken stuff in there, but we will debug it or I will fix it afterwards and you can see it in the repository. All the code I'm showing you will be on GitHub afterwards, so you can just play around with that as well. So who is using Java here? Okay, not that many. Who is using something else? Or who is programming in general? Okay. Just to use something hands-on, I'm using Java because I've used that a lot in the past. So I'm using the logging facade, SLF4J. The thing that writes out the logs is Logback. And I'm using structured logs, the map diagnostic context, MDC, to get data. I will show you some quick Java examples, but they're very simple and they probably translate to any other programming language. You can do the same thing with pretty much any other programming language. Even PHP has a proper log appender now. So even in PHP, you don't have any excuses to do print ln or whatever anymore to log. There you have monolog, which is very widely used. And pretty much every other programming language has a proper log appender where you can do similar things from what I'm showing you today. So first off, println or print or whatever for logs is an anti-pattern. I hope everybody agrees. Otherwise, we can discuss that later on, because you cannot really filter on what log level you want to get stuff. Also, you cannot add structured information, and you're just very limited. So let's assume we don't want to use print for logging. Let's say we agree on that. The other thing, what you don't want to have is tight coupling between your logging solution and your application. So you don't want to have like a proprietary or like logging specific import everywhere where you log. You want to use like a regular logging library for your programming language and then only process the data in a centralized fashion afterwards. So you don't want to kind of couple your application to your logging solution tightly. I assume everybody agrees with that as well. So the first thing, the good old approach is basically you start parsing logs. Who is doing that? You're basically writing out logs and then you start parsing them. Okay, that's surprisingly few. Who is generally working with logs here? Okay, more people. Okay, good, that's something. So the general architecture that we would have nowadays is that you write out your classical log file, then Beats is basically tailing that file and forwards it to Logstash. Logstash is doing the parsing, stores it into Elasticsearch, and then Kibana is showing you what is happening. So that's simple enough. So what do we even have here? So I think, don't worry, we won't see too much Java today. So I have a loop which iterates 20 times, and I am implementing some pattern here for logging. Basically, what pattern or what common thing are we doing here with our log pattern? It's a very common interview question. It's a good old FizzBuzz. Basically, we're doing the FizzBuzz like if it's divisible or divisible by 3, by 5, or by 15, you have different log messages. Basically, we have 20 log messages we want to emit. We log everything on trace where we have some iteration and session. These are like structured information we want to keep around. I'm also using them here as a structured event. And then depending on what position in the loop we're in, we're having an error, we're having a 1, an info, a debug, whatever. So we have one specific message here and one generic message here. So we will log 2 events for every round in the loop. How many log messages are you expecting in total? 40. Yes, that sounds good. So let's run this. No, not debug, but I don't have a breakpoint anyway. So it shouldn't make any difference. Well, that worked. We logged something. Let's head over to Kibana. So it's just large enough for everybody to see. This is a release candidate of 6.5 that will come out soon enough. You can see we added some more logos and we have some more promising things like logs, but I don't want to dive into logs, but we have a more focused log UI in the future, and we have a more focused infrastructure UI in the future as well, and we will get to that in the future. So we'll head over to Discover, which should show us that in Parse we have just collected events. The funny thing is that we have 42 here. Any guesses what could have been broken in my application? And you can actually see it in the output here already.
Multi-line?
Yes, multi-line. Which is kind of a common problem that you log line by line. And then here that stack trace is very short. But you still have these additional 2 lines here. And this is why we have 42 events. I mean, 42 is always the right answer, but not for our log example here. It should be 40. Because basically what I've done is I've said, like, collect every single line and sort it in a log. But breaking up a stack trace is not very helpful because one line of a stack trace is normally not helping you. So that's the first thing you would need to fix. Or actually, before we fix anything, let's see what we have been doing here generally. So we have a file beat to log stash where I say collect everything in that log file and then forward it to log stash. Fair enough. And then in log stash, I have basically said, well, there is something coming here from, so we have the beats input. We can see here, this is what we take. We apply that pattern to parse it, and then we basically store it into the parse index. And that's exactly what we have here. So here in the parse index, you can see for the loop, you can see here 20 appears twice. So these were the 2 events in that loop event where you can see, okay, we had a warning message here, and we had the message for the general run. And you can see I have the log levels. So I've extracted the log level, the logger, the loop event which was structured. Like these are the structured events with MDC. If your logger can do something like that, it's very helpful. If you have like the user that is logged in or the IP address or some structured information to pin down where that stuff is coming from. You have the original message, you have an offset, you have the source and all these things. So that worked pretty well. You just need to write that stupid grok pattern, right? Who likes writing regular expressions or grok patterns? And everybody who says yes, I'm always like, this must be Stockholm Syndrome, where you kind of got so used to doing that, that's kind of like, yes, we love doing that. I'm honestly not a big fan, but by the way, the nicest way to write grok patterns is, I'm not sure if you know that, but in DevTools, we have the grok debugger, where you can paste, let's cheat a bit and make this simple. Let's just take this line here. So this is our log line. And let's cheat as well. And let me just steal my log pattern, because otherwise nobody wants to see me type that much. And let's go to the beginning. So you can see something, it starts with a square bracket. Oops, that's the wrong way around. With a bracket, then we have a timestamp, ISO 8601, which we put into the field timestamp. Then there is a square bracket that's closing. Then there is 1 or more spaces. Then there is a log level that we put into the field level, etc. And then when you simulate this, it will show you actually what would come out of your grok pattern. So this is very handy if you need to write grok patterns, and it will take the pain of grok away a bit. But you still need to write, for every single log format that you have, you will need to write that line. So depending on how much you write like your regular expressions, that might be more or less fun. Okay. And I have it in the file already, but it's not enabled here. This would be the rule for the multi-line statement. So basically we're saying everything that doesn't start with a square bracket, because you can see every log message starts with a square bracket. Unless it's a stack trace, then it's not a square bracket, but something else. So unless it starts with a square, so if it starts with a square bracket, it's a new message. Otherwise, it's the continuation of a previous log statement, and it should be put into one message. And if you add that multi-line pattern, it will keep the stack trace in one piece, and then you would only have 40 log events and not 42 anymore. And you will not unnecessarily break up the stack traces. So that's helpful. You could also, for example, say in your log file, file beat to logstash. Here I had that line uncommented, that's why I didn't do anything. You could also include or exclude specific lines explicitly. For example, here we could say we want to exclude the trace messages because too much noise, we don't want to centralize that. So we basically kick out the trace here. So that's the parsing part basically. And yeah, to parse that one line, everything works. By the way, you can see I've used an emoji in my log, which doesn't look great in my Java application, because in Java it looks, this is the emoji. And this is supposed to be loop 15. Let's see if we can find it in Kibana, because I think we added that in 6 or in some version like that. Wait, what was the field that we had? Where's my application? What is the field where we had that user experience? So we should the user experience, and then you can see we support emojis everywhere now. Like full parsing, Kibana, and everything. Yes, most important feature of anything. Yeah, major change or major improvement. That's how you make your users happy. So generally, the nice thing about this approach is that you don't need to change your application. You can just keep logging the way you've always logged. You need to write regular expressions, which I personally don't like, but, well, depends. Sometimes your timestamps are off, and then you need to fix the timestamps as well. And you always need to be careful with multi-line statements to not break up your stack traces. The next possibility would be to take whatever your application is logging, and then you basically have everything structured when you try to write it out to your log. So why write it out to a log and then parse it back? We could send it in a structured format to our centralized logging system right away. So basically what you could do is you could just add another log appender. So just heading over to the log appenders, here's my Logback configuration. So what we did initially was I said, well, my application is writing out to a flat file, and that is the pattern. And this is what we're writing out. But instead, what you could do is you could say, I want to send this to Logstash right away. I don't want to put it into a file and then parse it back. I send it to Logstash, and it knows all the fields already in the same format. That works. I just think I've broken it in my demo, so I don't want to try this now. But it would do the right thing. So your setup looks something like this. Your application has the right log appender, which talks to Logstash directly, which puts it into Elasticsearch and into Kibana. And you don't need to do any parsing. Who is doing that? Anybody is doing that? OK. What are the downsides of this? Any downsides? No?
For transmission?
Yeah, that's true. I think, so it depends on the log appender. For example, Logback, I think, keeps 200 megabytes worth of logs by default. But if you reach more, if your receiver is down for more than 200 megabytes worth of data, you will lose those messages, yes. The other thing is kind of, if you have network trouble on a day, you will not receive your centralized logs. And probably then you care most about your logs. Because if stuff is not working correctly, then you want to see what is going on. If your logs mainly work in the sunshine case, it's kind of a stupid system, because in the sunshine case, you don't care about your logs that much. So the pros is you don't have files and you don't need to do that parsing. The main downsides are if your network is down, you will not see any logs. And you have kind of a tight coupling between your log appender and the receiving system. Also, if you have a bad log appender, there are some which don't, or which see that they cannot receive or reach the receiver, and they might open more and more threads over time. And we've seen cases where if the centralized logging system was down, the log appender would actually kill the production application. And that's kind of a coupling you don't really want. It depends on your log appender. So most good, or the good ones don't do that, but we have seen cases where log appenders killed the production application if your centralized logging management was down, which is not a good place to be in. Okay. The next thing is, what you might want to do is you structure your logs, which might look something like this. So you have another log appender which writes out in a structured format. Then the beats basically tail that file and store it into Elasticsearch directly, because, well, you don't have to do any parsing anymore because it's structured. So in my application, I could just write that out to JSON, and well, I have another log appender where I basically say all those fields that I have, instead of writing them to my log pattern here and writing it into one line, my log pattern should just write it into a JSON document. And then you also don't need to care about multi-line parsing and anything because, well, it knows how to approach that. So you just put everything into a structured format here, and then you can tail it. So that's pretty easy. OK. Which is good because it's the right format. You just have some serialization overhead for JSON, and you need that additional log appender. But generally, this is an approach we would recommend if you can. Like, if you can just add a log appender to your application, this is very easy, and you have very little overhead. And it makes consuming your logs pretty easy afterwards. Next up, containerize. What happens if you need to containerize stuff? I guess everybody is using Docker, right? Is anybody not using Docker? No, I mean, sorry. You're using some container technology that is not Docker. 2, 3. OK. That's more than I was expecting, because normally it's really almost exclusively Docker. By the way, I think the right logo for Docker is normally this, which is A, how Docker behaves, and B, this is also the size of your average container, right? Anyway, so Docker. Where do you collect your logs if you use containers? Or, yeah, making more fun of containers. Previously, it only worked on your machine, and now it only works in your containers. Maybe that's a thing, maybe that's not a thing. But you still want to collect those logs. So where do you put the beat to tail your logs? Generally, putting it into your container is not a great solution. We would recommend a sidecar, so you can just run the sidecar next to it, and it will keep tailing your files like that, which looks something like this. Basically, on your operating system, probably your Docker logs will end up in varlib Docker containers and then docker id.log. Basically, you say, OK, this is a log file. I will want to consume that. And one of the nice things that we can do, or that FileBeat can do, is it can enrich the Docker information into every log line. So you actually know where this is coming from. And the result of that, including that add Docker metadata, might look something like this, where you see the host, the port, and then you have this Docker metadata, where you see this is the ID of the container. You have the, bless you, the name of the image. You have the image. You have the name of the container. You have any labels that you have. And then in your logs, you could filter down on specific labels, for example, to say, like, only give me the Java applications, or only give me stuff that is based on a specific image. So basically, we resolve that against the Docker daemon once, and then the FileBeat keeps that information cached and enriches every following event with that additional meta information. And then you can simply search and filter on that information later on. If you have more like the classical application that doesn't write to system out, but wants to write to its own log file. Oh, by the way, one thing, if you use the approach of the default Docker JSON logs, you need to enable rotation because that's not enabled by default, which sometimes people forget and then fill up the disks, because rotation is not enabled on that file. If you have your own classical application that writes out to a path, what you would do is basically you would have your Java application, and you basically write out your logs to a specific folder that you mount out of that container. And then in your sidecar container, you mount in those log files and then consume that from the sidecar. And, well, your application then needs to do the rotation and everything on its own, but we can just consume that. So this would be where the FileBeat configuration is being loaded in the beat, and this is where the file or log file to be consumed would be. That's all you need. So this is how you could run that and consume that information. And for every application that you run, you would need to add the right volumes and mount them out of your application container into your log container to consume that. One thing that you might want to do is you want to externalize the registry file. Does anybody know why that might be a good idea? Or let's start somewhere else. What is the registry file in FileBeat?
Saves the position in the log file.
Yes, exactly. So basically, it keeps the file though it keeps the inode, which also makes it work across rotations, which is another very nice feature that even if you rotate the file, it will know that this specific file I have sent everything until this offset in the file, and everything afterwards is still missing, and that works across rotations. I have no idea how that works on Windows though, or if that works, and I don't even have a desire to try it out. Anyway, and so that registry file keeps a pointer of what has been sent and acknowledged by the receiver already. If you replace the container though, and that registry file is inside the container, you will start reconsuming all the log files again. That's why you might want to keep that registry file outside of the container on a bind-mounted directory. So if you replace, for example, you update the file beat, you update from 6.3 to 6.4, if you keep the registry file inside the container, that knowledge is lost, and we would try to reconsume all the log files that we can reach. If you mount the registry file outside of the container, we will keep the same registry file, and then we know what has already been sent away and not duplicate all the logs. So that's kind of a neat trick you should keep in mind. Some systems log crap like that. For example, Redis. And nobody wants to centralize that. I mean, it's cute and funny, and when you start, it is, oh, Redis is so nice. But nobody wants to centralize that because nobody wants to search for that. We have one additional thing where we can basically use templates, and in those templates, when we collect the log file, we could define a condition. So for example, we could say if the image is based on Redis, we want to apply some rules, and those are in that configuration block. And that configuration block basically says, I want to exclude any line that contains that ASCII art crap. And so that's one way to get rid of that. So you could have specific rules based on some label or name or base image or whatever meta information you have on the Docker container. You could filter down and exclude stuff based on that. Okay, good thing is it's kind of hot because everybody needs to use containers now. If you don't know containers, it's probably not the best place to start because I think 50% or so of the questions we get around containers and Elasticsearch are really Docker questions and not questions about our products, but we got used to doing part-time Docker support now, for better or worse. Okay, next up, orchestration. What orchestration is everybody using? Who is using Kubernetes? Who is using something else? Okay, also fewer. Because normally we see Kubernetes, and that's what we integrate into again. So whether you put your file beat, there is a daemon set where you can make sure there is one instance running on each host that you have, and that one can then consume all the log files from that host. We can include metadata, so if that container, the file beat container is running as part of Kubernetes, it can just use the metadata from its own cluster. If it's running outside of that, so if you would install that, for example, the file beat explicitly on the host and manage the rest with Kubernetes, you could still connect to Kubernetes and get information from its API. What you would get is that you have the enrichment both for the Docker base data, but you also get stuff like the node, the pod, and the namespace. And you can use that information afterwards where to put stuff. And you can filter out the ASCII art crap again, which looks pretty much exactly the same. What you can do is, for example, in the output, you could have a different index for every namespace or every pod that you have. It might end up being a lot of indices in the end, but you can do that. So what we're doing here basically is, since we enrich that Kubernetes metadata, if there is a Kubernetes namespace, use that as the index name, otherwise use filebeat. So that column means either if this is available, use this, otherwise go use filebeat, dash the beat version, dash whatever the date is. And we're using a daily pattern here, which might more sense to make that a weekly pattern or whatever. But that way you could break up your namespaces into different indices, for example. Yeah, it's kind of even hotter, but also the complexity is increasing. I think we are about to release like Helm charts for everything in the Kubernetes world. So we will even offer, while the beats can generally work well with Kubernetes, we will also offer official Helm charts soon to make the integration into the Docker the Kubernetes ecosystem better in the future as well. Okay, More stuff that you might want to keep in mind. Tiered architectures, hot, warm, cold. Anybody doing that for logging? Or anybody knows what they are? Okay, that's very few people. So what you generally want to do is, when you collect logs and you have this daily index pattern, for example, all your write operations will go to today's index. And you're not writing to yesterday's or a week ago's index anymore. So you might want to have different node types with different hardware architectures to make it cheaper. So for today, you might have faster nodes or nodes with fewer indices because you're doing a lot of write operations. And oftentimes, you also mostly search today's log data and maybe yesterday's log data. But very few people have searches that go back a month or so. So you could have different tiers of architecture. So you could have like hot would be like today's data where you write a lot and you search a lot. Then warm could be like yesterday to a week ago, where you also do more or less frequent searches. And then cold might be more than a week ago, or older than a week, because you very infrequently search those, and most people will accept if you search for something very old, you might have to wait a little longer. And then you would have different types of hardware, so very fast nodes for hot, with SSDs, and maybe you have faster spinning disks on the warms and regular spinning disks on the cold nodes or whatever to keep your hardware costs down. You have a multi-tiered approach, especially if you have a lot of log data and you have like 50 nodes in a logging cluster, you might want to have different tiers of hardware. Anybody knows how you actually put that together? So what you normally, or what you generally do is you say one node is, for example, you have a node attribute where you say this is a hot node, a warm node, or a cold node, for example. And then on an index, when you create the index, you say this index needs to go to a hot node. So when you create the index, it will go to today's node, and this is a hot node. And tomorrow, you change that attribute and say this index now needs to go to a warm node. And after a week, you'd say this needs to go to a cold node. And Elasticsearch, based on that tag, will move the indices around or the shards around accordingly. And you will also soon be able to manage that in Kibana. We call that thing index lifecycle management, and that will make your life a lot easier. Anybody using Curator, Elastic Curator, to tend to your indices? It's not a 100% replacement, but it is something that will take over a lot of what Curator is doing. So it's basically running as part of the Elasticsearch cluster, and you can manage it through Kibana. So what you get is you create, for example, a policy, and you say, like, we have a hot phase. This is today's data, for example. And we enable rollover, and we want to have an index maximum size of 3 gigabytes. Who knows what rollover is? Okay, rollover is helpful because maybe you have very different amounts of log data on different days of the week. So Monday to Friday, you might have 50 gigs of logs each day. And Saturday, Sunday, you only have 1 gigabyte of data. And then it's kind of wasteful to always create, let's say, 3 shards for every day, because Saturday and Sunday's data has too many shards. And there is no really good way around to do that, because with a daily index pattern and you say always create that many shards, there's no good way around that. With rollover, basically you can say, once you have your index has reached 3 gigabytes, create a new index and write all the subsequent data to that new index. And it will basically always create an index with a certain amount of size, regardless of how long that takes. So it could take like 3 hours until you create a new index, or it could take 48 hours until you create that new index. It will just know, and based on that rule, it will create the right indices. Next up, we could have the warm phase, where after 0 days, we basically create a rule where we say, okay, we want to move that to the different node type, which is the warm node, and also we want to shrink down the number of shards. So basically, or for example, we go from 3 shards to 1 shard when we move the data over to limit the number of shards and do that. You could also do a force merge or do various other steps. And then at the end, you could have that cold phase, where you could activate, here it's not activated, but you could activate the cold phase, and then we have a delete phase. After X days, you could just delete your data, or snapshot it before you delete it, or whatever. So that will make that a lot easier.
You just said that this is near to come. Do you have a release date?
Yeah, but we're never telling release dates. So, so I had hoped to be able to demo it already. Right. It slipped twice now, unfortunately. So what I can tell you is that it's not in 6.5 yet, but we hope to have it soon. I think that's already pretty specific. So it's unfortunately not in 6.5, which is this one here, but you get lots of other toys in 6.5 already. I'll have another slide on that. Index lifecycle management will be, but it will be next year. It will not be out this year. We hope early next year, but you know, no promises. You will have to wait a little longer. Then we have another thing called frozen indices. Are we running out of time? Okay, I'm done in 3 slides. Anybody heard of frozen indices? Yes. Frozen indices are kind of a new thing where we want to increase the ratio of disk size to heap. It will play some tricks on how many threads we have searching your data, and it will be much slower, but you will have a much higher storage density on a per node level. So basically, you will be able to pack more data on a single node because depending on how far you push it, maybe you have 2 to 5 terabytes of data maximum on one node. And the idea of frozen indices is to increase that size, that the storage density is higher on the per node level. There is an open issue, and I think it's also about to be merged or has already been merged, so that's also already pretty far along. You have the infra UI and log UI that I didn't really show in that example, but we have more customized and tailored UIs for that. And we will have in 6.5, there will be centralized beach management. So far you only have Logstash, centralized Logstash management. 6.5 will bring the centralized beats management. Though, I don't know, I like my configuration management. I always feel that this should be a job of the configuration management you're using. But some people really want to have that UI view where you put it into a central place and it will magically walk around your infrastructure. Anyway, to wrap up, if you want to get the code, I might push some more updates to unbreak my demo. This is where the Java example lives. It should be pretty easy to port that to any other programming language. So we had Parse, if you like to write regular expressions, but you can keep your replication the way it was. You can send it, for example, with a log appender directly to Logstash. The problem is, what if your network is down? You can structure it if you can add that right log appender, and it will make your life easier afterwards. Containerizing, you can add metadata, and you probably want to run FileBeat as a sidecar. And to orchestrate, you get metadata again, and you can run it as a daemon set, so you have 1 instance per node to collect your logs. And with that, any questions? Any questions?
So thank you, Philipp. Questions? Any Java developers in the room?
Yeah. It doesn't have to be Java. I take none. By the way, before you run off, let me take a quick picture so I can prove to my colleagues that I've been working. Because they don't know where I am normally. Smile, everybody. Okay, cool. Any questions now? Or did anybody post any question online? No. Yes, wait, let's go to questions. Are frozen indices searchable, or do they have to be thought first? No, they should be searchable. They will just be searchable slower. Right now we have that concept that you can close an index, then it's not searchable. The one downside of a closed index is that if a node dies, we will not replicate it again to another node, but that will probably change in the future. So the differentiator is you have a closed index which is not searchable. That would need to be kind of unclosed or opened again, then it's searchable. The frozen indices are searchable, but just searchable slower. And by the way, we have another thing that comes out that will make your snapshot smaller. It's called source-only snapshots. Because right now, your snapshots contain basically all the information that you have in your index. And you have all the inverted indices and everything in your snapshots. There will be a new option where you basically only snapshot out the raw JSON data that you have put into your cluster, which will have very limited search features when you re-import them, and you would need to do a re-index, but you can kind of keep a more compressed or limited snapshot of your data in the future as well. Any other questions?
Okay, thank you.
Thank you.
And a little gift.